National Electrical Code Article 358 covers liquidtight flexible metal conduit and liquidtight flexible non-metallic conduit. Section 358.10 states stainless steel or zinc-coated steel liquidtight flexible metal conduit shall be permitted to be used as an equipment grounding conductor. This code section specifically allows the use of stainless steel liquidtight flexible metal conduit as a means of grounding for electrical equipment. It is important to note that this does not explicitly specify the use of stainless steel tubing as a conduit for low-voltage wiring or control wiring. Now, let's consider the National Electrical Manufacturers Association, or NEMA, standard publication WF6-2020 titled Stainless Steel Tubing for Fluid Power, Process, Food Industry, and Sanitization Applications. Section 5.4 of this NEMA standard indicates that stainless steel tubing shall not be used as a conductor. This standard publication specifically prohibits the use of stainless steel tubing as a conductor for electrical current. In conclusion, while the National Electrical Code allows the use of stainless steel liquidtight flexible metal conduit as a grounding conductor, it does not explicitly allow the use of stainless steel tubing as a conduit for low-voltage wiring or control wiring. Furthermore, the NEMA standard prohibits the use of stainless steel tubing as an electrical conductor. Therefore, using stainless steel tubing as a conduit for low-voltage wiring or control wiring is not considered an acceptable method for this application. It's essential to differentiate between stainless steel liquidtight flexible metal conduit, which the NEC permits for grounding in certain circumstances, and stainless steel tubing, which NEMA prohibits as an electrical conductor. The NEC addresses the installation and safety requirements for electrical wiring and equipment. It's updated regularly to reflect current practices and safety standards. Article 358 specifically focuses on liquidtight flexible metal conduit and liquidtight flexible non-metallic conduit, outlining approved uses and installation methods. When considering using any material as a conduit, it is important to consult the relevant articles in the NEC to ensure compliance and safety. The section allowing stainless steel liquidtight flexible metal conduit for grounding means that when used as a grounding conductor, it provides a safe path for fault current to return to the source, thus minimizing the risk of electrical shock or fire. However, this allowance does not extend to using standard stainless steel tubing as a general-purpose conduit for carrying low-voltage or control wiring. NEMA, on the other hand, develops standards for electrical equipment and medical imaging. NEMA Standard Publication WF6-2020 provides guidelines for stainless steel tubing used in various applications, including fluid power, process, food industry, and sanitization. The prohibition against using stainless steel tubing as a conductor stems from its material properties and intended use. Stainless steel tubing is designed for mechanical and fluid handling purposes, not for electrical conductivity. Using it as a conductor could pose safety risks due to its potential for overheating, corrosion, and inadequate insulation. Firstly, verify the specific application requirements for the wiring. Secondly, consult the NEC and other relevant standards to ensure compliance. Thirdly, choose approved conduit materials and installation methods. The NEC provides detailed specifications for various types of conduits, including their approved uses, installation requirements, and grounding methods. These specifications are designed to ensure the safety and reliability of electrical systems. When selecting a conduit material, consider factors such as environmental conditions, mechanical stress, chemical exposure, and electrical requirements. Different types of conduits are suitable for different applications. For example, rigid metal conduit provides excellent protection against physical damage, while flexible metal conduit allows for movement and vibration. Non-metallic conduit is suitable for corrosive environments, while liquidtight conduit provides protection against moisture and fluids. The grounding requirements for conduits are specified in Article 250 of the NEC. Proper grounding is essential for electrical safety, as it provides a low impedance path for fault current to return to the source. This helps to minimize the risk of electrical shock and fire. The NEC also addresses the use of equipment grounding conductors, which are used to connect the metal parts of electrical equipment to the grounding system. Equipment grounding conductors must be sized and installed according to the NEC requirements. Failure to comply with these requirements can result in electrical hazards and equipment damage. In addition to the NEC, other standards and regulations may apply to the installation of electrical wiring and equipment. These may include local building codes, industry standards, and manufacturer's instructions. It is important to consult all relevant standards and regulations to ensure compliance and safety. When in doubt, consult a qualified electrical contractor or engineer. These professionals have the knowledge and experience to ensure that electrical systems are installed safely and in compliance with all applicable codes and standards. It is essential to use listed or labeled equipment, as this indicates that the equipment has been tested and certified by a recognized testing laboratory. Listed or labeled equipment meets minimum safety standards and is suitable for its intended use. Using unlisted or unlabeled equipment can pose safety risks and may violate electrical codes. It's also important to follow the manufacturer's instructions for installing and using electrical equipment. The manufacturer's instructions provide important information about the equipment's limitations, safety precautions, and proper operation. Failure to follow the manufacturer's instructions can result in equipment damage, electrical hazards, and voiding of warranties. The NEC is not a design manual, but rather a set of minimum safety standards. It is up to the designer and installer to ensure that the electrical system meets the specific needs of the application. The NEC provides guidance on how to select and install electrical equipment, but it does not specify the exact design of the system. The design of an electrical system should take into account factors such as the load requirements, voltage drop, conductor ampacity, and overcurrent protection. These factors should be carefully considered to ensure that the system is safe and reliable. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. Maintenance should be performed as needed to keep the system in good working order. Electrical systems should be protected from physical damage, moisture, and corrosion. These factors can degrade the insulation and conductors, leading to electrical hazards. The electrical system should also be protected from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect the system from these conditions. The NEC requires that overcurrent protection devices be sized and installed according to the code requirements. The NEC is constantly evolving to reflect new technologies and safety practices. It is important to stay up to date on the latest changes to the NEC. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. Staying up to date on the NEC can help to ensure that electrical systems are installed safely and in compliance with the latest requirements. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the potential hazards and take precautions to avoid them. Electrical safety training is essential for all electrical workers. This training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Electrical safety training should be provided by a qualified instructor and should be updated regularly. Personal protective equipment, such as gloves, safety glasses, and insulated tools, should be used when working with or around electrical equipment. This equipment can help to protect against electrical shock and other hazards. Personal protective equipment should be inspected regularly to ensure that it is in good working order. Electrical work should only be performed by qualified individuals. Qualified individuals have the knowledge, skills, and experience to perform electrical work safely and in compliance with the NEC. A qualified individual should not attempt to perform electrical work, as this can be dangerous. If you are not qualified to perform electrical work, consult a qualified electrical contractor or engineer. These professionals can perform the work safely and in compliance with all applicable codes and standards. Remember to energize electrical circuits before working on them. This is the most important safety precaution that can be taken when working with electrical equipment. Energizing the circuit eliminates the risk of electrical shock. Before de-energizing a circuit, verify that the correct circuit is being de-energized. This can be done by using a voltmeter or other test equipment. After de-energizing a circuit, lock out and tag out the circuit breaker or disconnect switch. This will prevent the circuit from being accidentally re-energized while work is being performed. Use insulated tools when working on electrical circuits. Insulated tools can help to protect against electrical shock. Insulated tools should be inspected regularly to ensure that they are in good working order. Maintain a safe working distance from energized electrical equipment. This distance depends on the voltage of the equipment. The higher the voltage, the greater the safe working distance. Never touch electrical equipment with wet hands or while standing in water. Water is a good conductor of electricity, so this can create a shock hazard. Be aware of the location of overhead power lines. Overhead power lines can be dangerous, even if they are not touched. Maintain a safe distance from overhead power lines. If you must work near overhead power lines, contact the utility company to have the lines de-energized or insulated. Report any electrical hazards to the appropriate authorities. Electrical hazards can include damaged wiring, exposed conductors, and overloaded circuits. Reporting these hazards can help to prevent accidents and injuries. In the specific scenario of the dairy processing plant, consider the environment. Dairy processing plants are often wet and corrosive environments. Therefore, the choice of conduit material is crucial. Stainless steel liquid-tight flexible metal conduit might be suitable for certain applications where flexibility is needed and grounding is a concern, but it must be used in accordance with the NEC and other applicable standards. However, for general wiring runs, other types of conduit, such as rigid PVC conduit or stainless steel rigid conduit, may be more appropriate. These conduits offer better protection against moisture and corrosion. When installing conduit in a dairy processing plant, it is important to seal all fittings and connections to prevent moisture from entering the conduit. Moisture can damage the wiring and create electrical hazards. The conduit should also be properly supported to prevent it from sagging or becoming damaged. The wiring inside the conduit should be suitable for wet locations. This means that the wiring should be insulated with a moisture-resistant material. The wiring should also be sized correctly for the load it will be carrying. Overloaded wiring can overheat and cause a fire. All electrical equipment in a dairy processing plant should be properly grounded. Grounding provides a low impedance path for fault current to return to the source, which helps to prevent electrical shock. The grounding system should be inspected regularly to ensure that it is in good working order. Dairy processing plants often use sensitive electronic equipment. This equipment can be affected by electrical noise and interference. To minimize electrical noise and interference, the wiring should be shielded and grounded properly. Surge protection devices can also be used to protect sensitive electronic equipment from voltage surges. Electrical work in a dairy processing plant should only be performed by qualified individuals who are familiar with the specific hazards of this environment. These hazards can include wet locations, corrosive environments, and sensitive electronic equipment. Qualified individuals have the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and standards. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems in a dairy processing plant. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. Maintenance should be performed as needed to keep the system in good working order. By following these guidelines, you can help to ensure the safety and reliability of electrical systems in a dairy processing plant. Always prioritize safety and consult with qualified professionals when in doubt.